Okay, good morning, good afternoon, good evening, everyone. Thank you all for joining. Really fantastic to have all of you here. My name is Karan Wazirani, and I am the technical specialist at Udacity. I look at technical operations for all the nanodegrees under the School of Business. And I've been involved in the Udacity ecosystem since 7 years now. So I was a project reviewer for the initial 4 years, 2017 to 2021, and then I transitioned into my current role as a full-time employee. Great to have you here for our final session of 2024 in the Digital Deep Dive webinar series. And in this series, we sort of explore topics that go beyond our classroom curriculum. And the idea is to provide you with insights from mentors who work on the Udacity platform. Joining us today is Ayushi. So Ayushi is our in-house subject matter expert for the School of Programming and for the School of AI. And she has a wealth of experience in the edtech sector. She's worked for over 5 years in this sector. Great bouncing board. So if you ever want to reach out to Ayushi, talk to her about programming and AI topics, please feel free to do that. Thanks, Ayushi, for being here. Uh, Finally, let me welcome the star of the show, and that's Thiago. He's our presenter. Thiago is a data scientist and a machine learning engineer, and he's been active on Udacity since 2018. And in the last 6 years, Thiago has done over 19,400 project reviews. Aside from project reviews, he also helps out in maintaining content on the platform. He's involved in one on one and one to many mentorship. So he brings to the table a very, very large amount of experience and a lot of expertise. And we're really fortunate to have him here to share his insights with us today. Before we begin, I'd like to uh, highlight a few housekeeping notes. One, of course, the session is recorded. And if you have any questions, feel free to post them in the Q&A tab. We have a dedicated section towards the end of the session. That's like about 10 minutes of Q&A. So we'll take up all your questions in the Q&A. Just one request, please don't put your questions in the chat window. We might miss that. We won't we sort of want to keep everything a little bit structured. So please feel free to put the questions in the Q&A tab. And with that, I'll hand it over to Thiago. The floor is yours, Thiago. Let's get started.
Okay. Yeah. Thank you, Karan. Thank you, Ayushi, for having me here. It's a pleasure to be here to be talking about some of the most recent topics in the generative AI, or what I could say, it's a trend topic, it's a hot topic to discuss. And it's a pleasure to be here to have this conversation with you all so we can all learn together. We can all put our experience and learn together, right? So let me share my screen. Let me start the presentation. Let me explain how this is going to be today. Okay, here we go. I hope you all can see my screen. And this is the topic that we are going to discuss. It's not only about generative AI, but we are going to talk about context and semantics in LLMs and how we can improve our LLM systems using vector database and RAG systems, right? So we're going to discuss a lot of those concepts. We are going to have some at the end some live code. I hope I can bring some news to the table for you all, and we can all learn together. During the session, there will be some quizzes, so we can break the ice. You can interact with me. You can put your answer, your knowledge, improve. So yeah, this is the topic: context and semantics in LLM, the role of vector database and RAG system. Okay. This is me. I'm Thiago. I'm currently working and as a data science and a machine learning engineer. So as Karan said, I've been here at Udacity for several years now. It's been a pleasure. It's been very enriching to my career, to my life, to help students and yeah, to be part of this community. And yeah, please join me on LinkedIn. Feel free to send a connection request. It will be a pleasure to have you there as well. So let's get started. This is our agenda. Four main topics here: how LLM works, a quick recap, right? Not going into much details here. So then we're going to talk about vector databases and how vector databases actually structure the vectors and how we can retrieve a meaningful vectors or meaningful context from it. Then we're going to talk about the RAG system itself, how it is, its advantages, and also the disadvantages that RAG system has, right? And at the end, I will bring a live coding, or I will show one simple notebook, a Git repository, where we can find some example how a RAG system can help us to get better results from LLM. Okay, so this is our agenda. This is how it's going to be for every topic here. Expect one quiz, and I hope we all can have some fun together. Okay, so this presentation is designed for who has some exposure in machine learning. You don't need to be expert, but you should know that machine learning exists at least, and how companies and people can benefit from the usage of machine learning and also generative AI. And at the end, we hope that you all can get a full understanding or an accessible introduction to the LLM, of course, but also to the RAG and how we can improve our systems or our LLM prompts using RAG in the system. Okay, so let's talk about LLM, right? How LLM works. I'm sure everyone here, at least once in a lifetime, has interacted with LLM, either ChatGPT or any other provider. So we also, or usually, we have one task, right? Or we try to accomplish one task using LLM. Either a summary of something can be feedback, or generating something that could be an email, right? We have one given task that we want to accomplish, and we want the LLM help us to do, right? So in order to ask an LLM to do those tasks for us, we have a prompt. And inside this prompt, we have some instructions to complete that task. We might also add some examples, and that comes from a whole prompt engineering that we will not cover today, but we can add some examples to help the LLM to understand what we want and the way we want our output. But we can also add some context, right? And this word or this term context is very important in our conversation today. Because, for example, if I ask ChatGPT what happened yesterday or what happened 5 minutes ago, maybe it will not be able to answer our question because it was not trained on it. It was not trained on this specific or on this recent data. So adding context to the prompt allow us to inform LLMs what we actually want or the context of my instruction, right? So we pass everything to the LLM as a prompt, and then we get a generated text, or our task is completed by an LLM. So I think we all know this. Maybe the context part or some prompt engineering steps are not very familiar to all of you, but that's okay. In a nutshell, we know how LLM works, or we know how to use the LLM for our benefit, right? But giving a little bit more context about LLMs. So large language models, or LLMs, are trained on a massive data set. So data set from internet, so text, image, whatever type of text or whatever type of data we have, it can be used to train an LLM. Usually, the architecture is using a transform architecture with a self-attention, and of course, it's a deep learning architecture, right? So this is one of the most foundational parts of LLMs, using transformer and self-attention. Usually, they use self-supervised learning, meaning that they use their own text and they kind of put some placeholders in text so that they can help the LLM to predict the word, and then We also know the word, so we can use a self-supervised learning to make this training loop happen. And one of the key things of LLM is that we can fine-tune our LLMs into one specific part. I'll make a parenthesis here about fine-tuning because it's really interesting. So, for example, we want to host our own LLM in our cluster or in our server, or either personally or for our company. And then we can fine-tune our LLM into specific internal data that the data that is not available for training before. So we can fine-tune our LLM to answer specific questions to our needs or to our internal data. This is different than adding context, right? So we are fine-tuning our model using different techniques, but we are fine-tuning our model with a set of data that it wasn't shown to the model before, right? Closing these parentheses here, moving forward. Now, let's see some examples, right? So how they are trained. So we can have this massive amount of data and we can ask to predict the next word. So imagine that we have this sentence, the dog likes to play with you. So we can ask the LLM during the training process to predict the next word. So we put this placeholder into this next token or this next word or a placeholder on it. And then the LLM is challenged to predict the next word. And then we can compute all of the things that are involved in the training process, gradient descent and the derivatives and so on and so forth. But it's not only about to predict the next word, right? We can also use LLMs to predict longer sequence, to complete longer sentence, and also to complete code for us. So if we have a task that it's involved coding, there are LLMs that can help us to code. So maybe you have worked with Copilot or also coding. So those are LLMs that help us to code or to help our productivity. Okay, I hope you get a sense of LLM, how it works, in a nutshell, how it is trained, and how we can add context in the prompt. So let's give a pause here. Let's make this a quick quiz here, and let's try to answer this question, right? Which of the following is not a way LLMs are using to music? So we are now in a music context. So let me launch the first quiz. So it will pop up in your screen. So you all have 30 seconds to answer this question. Okay. So yeah, here we go. Which of the following is not a way LLMs are used in music? Composing new songs. Can we use LLMs to make new songs, or to make a recommendation system to help us to suggest music, tuning guitars, music generation, or blog posts? Yeah, 5 seconds. Okay, here we go. Thank you all for answering. Let me end the poll and let me share the results. Yeah, we can compose new songs. We can make some recommendation to the listeners. Imagine that we have a set of songs, and I can ask, hey, I like rock music from these songs. Give me one recommendation. We can generate music content like blog and post. This is text generation, right? But still, we cannot tune the guitars. We still need one person to actually go to the guitar and tie the strings and everything, right? So LLM can help us in some stuff, but not every single stuff. Okay, so let's move forward. Let's now talk about our next stop, which are embeddings, right? So we are moving forward to the RAG system. And one of the key components when we are understanding unstructured data is to embed this data into vector of numerical values. And this is very important because in general, computers do not understand text or do not understand images or music. They understand numbers, and vector of numbers is what embeddings are for us. So the embeddings, it tries to capture the meaning or the semantic meaning and context of that input data, right? Usually, embedding models are encoder architecture, meaning that we have an input, either text or image. It could be a multimodal, right? It could be text and image. So the possibilities are endless. But imagine that we have a text and we encode this text or we encode this image into a vector of numbers. And depending on the size of this vector, we capture meaning in different parts of the vector given our input. So if we're talking about one text that contains information about one country, and then at the end of the text, it gives us information about another country, we expect that this embedding contains two different parts that represent the first country and then the second country. So it's a way to represent our input data into numerical values, but it also should contain semantic meaning and context into those values, okay? So, as I mentioned, we might have different models or we might have different types of input data, and for each input data, we might have different models. So we have dedicated models to embed image, we have dedicated models to embed text, and so on and so forth. And that's important because if you choose one specific model to your system, you cannot switch your model the way you want, right? So if you are capturing the meaning of the first text using, let's say, the GTE large, one specific model, and then you try to capture for a different text using another model, the embeddings will mean nothing to compare against each other. At the end, what we want is to embed a lot of documents, to embed a lot of images, and compare them. And in order to compare these input data, we have to make sure we are using the same model. Otherwise, the vector of numbers are not comparable, okay? So speaking about how to compare embeddings, we have to talk how these embeddings are represented in the space. So we have a vector of numbers, and imagine that we can represent this number into a space, right? In this example here, I have on the left side some animals, and on the right side, some fruits, and also two brands that we all know, Hugo and Apple, right? So when we use in a specific model, it understands that the fruit banana and the fruit apple are comparable. They are close to each other because they are fruits. So our embedding model make those close to each other in this multidimensional space. On the other hand, a chicken, a cat, a dog, and a wolf will be on the quite opposite side of this multidimensional space because they are not fruits, they are animals, right? But there is one specific thing that happened, and we have to be aware, is that, for example, Apple is also a brand, and the Apple company or the Apple brand is close to the Apple fruit. By consequence, Google is also a tech company, and it's close to Apple. Then Google is also close to the fruit Apple. So those things happen when we embed different input data into a multidimensional space. And then we have to compare those vectors to extract what we really want from those embeddings. Having that said about embedding comparisons and how they are in the multidimensional space, we can use several metrics. And we're going to focus on the cosine distance here, or the cosine similarity, which is 1 minus the cosine distance. But we could use different metrics or different distance to calculate and to get the difference between those vectors. We could use Euclidean cosine, Hamming distance, or Manhattan distance. So it will depend on the use case. Most common or the most common distance that we use is the cosine distance. There is some reason behind it, But yeah, let's focus on the cosine distance. And using those type of distance or using one metric to compare the embeddings, we can look into all of our embeddings or into our vector database and decide, hey, if I'm talking about one specific author or one specific book, give me the text that is most similar to that book or to that specific author phrase or something, right? So we use this kind of metric. But there is one thing. Imagine that we are in a system and we are years and years collecting data, embedding data, storing data. So imagine that my database is increasing and it's a large database. So if I want now, 3 years after starting my system, to compare against every single vector, it can be very costly, and the answer to the user might have some delay that we don't want the user to experience this kind of delays, right? So there is one thing that it's important to know uh, about vector databases, and that's our next talk when we are going to talk vector databases and how we are going to get the most important thing from our vector databases. But before moving to that, let's go to our second quiz and make sure that we understood what embeddings are and what the purpose of the embedding. So let's have um, our second quiz. Let me put on the screen right now. 30 seconds again. Here we go. Yes. What is the primary purpose of an embedding model? To store data sets, to convert text into data, to other data into numerical vectors, perform data encryption, or to visualize data. Here we go. So more 5 seconds. Thank you all for giving a shot here. Hey, 30 seconds. Thank you all. Let me end the poll here. And yeah, the majority answered correctly. Let me share the results. Yeah, to convert text or any other data or unstructured data into numerical vectors, right? So let me stop sharing. Let's go to the vector database. I start talking about vector database and the importance of comparing. So let's give one step back here and talk about some of vector databases available in the market. So there are a lot of them. Maybe in this image, there is maybe the most important ones. I don't want to be mean to anyone that is not here, but we have two types of vector database, or we can classify them in two main types. So we have dedicated vector databases, which are really vector databases only. And we also have databases that are databases that we can use for usual use cases, but they can support vector search. And pay attention into this expression vector search, because that what make our vector databases, or that what make one of the choices we do when we use vector databases for generative AI assistance a good approach, right? So we have some open source ones and we have some commercial ones that you can choose. It will depend on your company needs, on the policies they follow, or your clients. It has a lot of pros and cons on each one here. I'm not here to advocate for any one of it. In our example, we're gonna use ChromaDB. So because it's open source and it's easy to handle in a notebook, but you can also use PostgreSQL because it's close to Postgres, and Postgres is a really used database in many systems. So it will depend. There is no right, no wrong answer here, right? But speaking about the support vector search, that's important because, as I was mentioning, when we increase the number of vectors in our database, we want to compare every single vector, or we want to compare the context that we want to the vectors to make sure, hey, this is the most similar vector that I have. And the way vector databases do under the hood is they use some ANN algorithm or approximate nearest neighbor algorithm, or at the end, they create kind of clusters of vectors. So it makes the search easier and faster. So imagine now that I have one specific question or one specific context request to my vector database. Instead of looking to all of the vectors, it understands using indexes or clusters where the most probable answer to my vector is. So instead of looking to all of the space, all of the multidimensional space, it will look into specific vectors that are inside this cluster. This is important because it makes the search faster. But on the other hand, we might lose some vectors that are on the boundary, and probably it will not be verified. But again, it's a trade-off. We gain speed. We might lose some good answers. Maybe they're not so good. So yeah, it's worth to have more speed and lose a little bit of accuracy in the search, right? So this is why vector databases are important. And that's why vector databases are very, very used in this new generative AI ecosystem or in generative AI system, okay? And now, if I could put everything into a single flow or into a process where we can understand where my data is and where my embeddings are going to, let's think about this process, right? How we process embeddings like we're trying to process the data, right? We have our text or we have our input data. And here I'm adding one additional layer that I didn't speak before, which is splitter. And imagine that I have one simple paragraph that I can easily embed, right? It's a single paragraph, maybe 4 or 5 lines of text. That's easy. But imagine that I have to embed a whole book with a lot of chapters, a lot of paragraphs, a lot of information in it. So it's a good idea that I can split this book into chunks, or I can split this book into chapters or paragraphs. And the way we do when we are processing embeddings is splitting into different chunks, right? We call here chunks. And those chunks can be represented by paragraphs, as I mentioned, but you also have some specific strategies to split your text, okay? You can use a semantic splitter, for example, which you use an LLM to help you to understand that part of the text. And it says, hey, until this specific line or until this specific word, it's one topic. From now on, it's another topic. So you split your text in this specific character or in this specific word. That can be doable. But the most common one, and we're gonna stay on it, you can all search for different splitting strategies, but the most common one is token splitter, or we split our text by token. So let's say I have 300 tokens split. So every 300 token, we split our text and create another chunk. This is easier. This is faster, to be honest. Using an LLM to analyze the text and give, hey, this chunk 1, this is chunk 2, can be costly and can be not very effective in terms of data processing. But yeah, token splitter is a good option, and we have some ways to verify or to evaluate if that is efficient enough. But again, evaluation is other topic we can cover in the Q&A part. So going back to our pipeline here, we have a splitting. Now we know how we can split the text or split our documents into different chunks. We pass these chunks or we pass these documents into our model. Here, our model is GTE large, right? And this number, 1024, is the output dimension. So it will create for every chunk one vector of this size, right? So every vector, every chunk is one numerical vector with 1024 units or positions, okay? Then we can take this chunk or we can take all of these chunks and insert to our vector database. And here I'm calling it vector store, vector database, vector DB, many names for the same thing. It's a vector database with data. Okay. So this is the process. It would be more or less the same for image. The process to embed our data is pretty much the same. Of course, you could use different strategies, parallelization, using different orchestrator to process this data. But in a nutshell, this is how we process embedding for text, for example. So moving forward, let us think that, okay, I have my data into my vector DB. I have my vectors stored, and I want to retrieve data from it. So in this example here, I have in my vector store information about machine failures. So imagine that I'm from a manufacturing company, and I have a lot of information about the logs of that machine, why it fails, when it fails, and everything. And I have a prompt. And by prompt here, I'm asking something to the vector store. But a parenthesis here, a vector store is not an LLM, right? So it will not generate an answer for us. It will not summarize anything for us. The process is different, okay? So let's go here and let's try to understand what's going on. We have a prompt, and my prompt is the last failure of my machine due the error ER12345. The process is I embed this prompt or this question using the same model that I use to process my embeddings, or the DT large. It will create, it is not a chunk, but it will create a single vector for my answer, right? And then this vector representing my prompt will be added to the vector store, or my vector store will compare my vector against all of the vectors inside that specific cluster, as I just demonstrated. So as we expect, as an output, we can expect the top K most similar answers, or the top K results for that specific prompt. I can ask 1, I can ask 2, I can ask as many as I find it's important to have. In my example here, I'm asking the two most relevant answers. So, and alongside my answer, I also get a score, which means the cosine similarity for that specific. It could be another distance metric, but as I mentioned, let's focus on the cosine distance, right? So according to the last register, there was a failure ER12345 in, and the text continues, but this is not the vector store generated. This is one specific text that it was inside my vector store. So it was just getting one part of that vector that makes sense. And we can think that the error code ER12345 is the key that make my score greater than the second one, which the failure is ER12311, right? So they are different, and we expect that the scores are different for each one of the possible outputs. Okay, so this is the process that we do to retrieve an answer from a vector DB. And it can also be used for image, for example. Now we have a multimodal model. We get a prompt. We convert into embeddings. I want a desk for children or for my kids. And then the output can be one very colorful desk, or one more professional desk. But as you see, the scores are different, and the higher the similarity, the better the answer. Okay. So this is the process. This is what vector DBs is meant to, and this is how we process embeddings in two vector databases, and how we can retrieve answers from the vector DB. Let's make our third quiz here and ask, what is a vector in the context of vector databases? So let me launch my third quiz here. And here we go, 30 seconds. So what is a vector? A mathematical representation of an object in multiple dimensions. That's long. A simple text document, a graph, or something related to design. Here we go. Thank you all for sharing your answers. 5 seconds to go. So 30 people already. Okay, 30 seconds. Thank you all for sharing your knowledge and participating on this quiz. Let me end the poll. Again, 90% answer correct. Thank you. Yes. So a vector is a mathematical representation of an object, can be a text, can be an image in multiple dimensions, or a vector of numbers. So finally, let's talk about RAG. So we understand what LLMs are. We now understand the importance of a vector database and how we can retrieve answers given a question or a prompt, right? So a RAG means Retrieval-Augmented Generation, meaning that on the left side, I have what we call retriever, and on the right side, we have what we call generator, right? The left side is composed with an external knowledge, meaning a vector database, and one retriever, which process our prompt, convert the prompt into the vector and make the comparisons inside the external knowledge. And on the right side, we have a given LLM that receives the prompt and the results from our vector database. So let's digest this information. Let's go on the retriever side, and then let's go to the generator side. So how we can retrieve meaningful answers and then use those answers. So we have a prompt, we have a question, or we have something that we want that our vector database or our external knowledge give us. So we pass this prompt or question into one tool called retriever or vector search, or one engine that get the prompt, use the same model that was used to ingest data into our vector database. It makes this question to the external knowledge or the vector database, and it returns the top K or the most relevant information given that prompt. Then this retriever or this vector search will take these ranked results and we'll add into the generator with the prompt. So now we have a prompt on the generator side, which means this is the task, or this is the instruction that we want. So imagine that, hey, I want to summarize something, or I want you to create some email sample for me using the result that is coming from the vector database. That's how it works. The prompt on the right side, on the generator side, contains the instructions, and the ranked results contain the context, contain the information that I want now my LLM to know before providing me the answer. That's how RAG system works. We have an external knowledge where we can enrich our prompt with contextual information, because LLM does not know my internal data, does not know some real-time information, and then we pass to the generator, to the LLM, to give an output or an answer for us. So going back to the failure example, how this RAG would work here. So again, I have a prompt. On the left side is my context retriever, and on the right side, or in the center, sorry, is my LLM, is my generator, and on the right side, I have the output or the answer from a system. So as my prompt in my context retriever side, so I want to know, according to the last register, there was a failure ER12345. So it's embed using the same GTE large or the same embedding model. It is passed to the vector store or the vector database. It computes the cosine distance or Euclidean distance, whatever metric you want to compare your vectors. And if you ask only one context or the most relevant context, it will give you one. It could be the top K, and we all know this top K history. But yeah, here we are asking the most relevant one, and the most relevant answer for this simple example is the machine XPTO register ER12345 failure on, and the tax continues here. Okay, so this is the context most relevant. I'm adding this to the LLM and also the prompt, and the prompt contains the task or the instruction that I want. Summarize the last errors that happened with the equipment and list solutions. So now my LLM will generate a summary of recent errors with that specific equipment. Now my LLM knows that my equipment XPTO exists and my error code ER12345 happened in a specific date, one specific occurrence, right? My LLM could be fine-tuned to understand that the description of this error has one resolution, or the description or resolution could be inside my context, right? And the LLM is just putting everything together in a human readable summary of the error. It might happen here, a fine tune of my LLM to these errors, or my context could bring everything, and I'm using the LLM just to structure the output. I mean, the design of the system or the design of my architecture here can be different ways. But the main point here is we are adding context to our LLMs. So what problem our RAG system tries to solve is LLM don't know business domain or specific data. And I'm not going to judge or to start a discussion about security or data leakage here. We all know that this is important. And LLM, ChatGPT probably shouldn't know about our internal data as well. But using RAG, we can safely, or if you use an in-house model, we can add context to our data or real-time information into our LLMs, right? Also, LLMs are mostly trained from internet data set. So that information can be accurate, cannot be accurate. We don't know. It's useful, but maybe for our use case, for our context, it's not useful at all. And then we need to add the correct context that we want in our answer, right? Also, LLMs have no memory, right? So imagine when you open a ChatGPT window, it has that short memory there, but if you close, maybe it will lose this information that you were discussing with LLM, right? So it's also important to add this kind of memory. Imagine in a chatbot use case where you want to have memory of what this specific user discussed last week or month ago. So when the user start interacting again with your chat, your LLM or your system will understand using a vector database what happened in the past, right? So those are the problems that RAG system tries to solve, and this is how we can take advantage of RAG. Okay. So again, our final quiz. What is the primary function of a RAG system? That should be the final proof of our understanding during this almost 50-minute session. So 30 seconds, please give your best shot here. Is it only to generate data, to classify, encrypt data, augment, generate content with retrieved information? Yeah. Usually the longest one is the best, right? Yeah, 30 seconds. Thank you all for sharing a thought here. Let me end the poll. And that was easy, right? To augment generated content with retrieved information from our vector databases. So let me pause here. This was the presentation about RAG system. So we had an understanding about why vector databases are important, why we have RAG systems and what is the type of task or which type of problem RAG system can help us, okay? So what I would like to do now is to stop sharing my screen or my presentation, open here a Jupyter Notebook. Maybe I cannot go into every single detail of the notebook, but I will share the repository so we can take a look and read the code after, right? But let's do it together, right? Let's make it happen. Let me stop sharing for a moment. I will do in the chat. What I will do in the chat is to share the repository so we can play with it. Just a second. Here we go. Here is the repository. Let me share my screen now. Okay, yeah, here we go. Here we go. Let me put it here. Yeah. Okay, so this is the notebook. So this is a very simple RAG system here. It's in the repository. You can clone, you can play around. Let me just give you some context here about this project. So first of all, imagine that we are working for a company that sells car, and we have our stock or the cars that is supposed to be sold, right? And what we want to do is, if a user engage with our system, it will ask, hey, I want one specific car with that feature, and I want my system to be not, if you want one specific car, these are the options. No, I want to understand the query, or I want to understand what the user wants, and then search in our internal vector database, okay? We're gonna use ChromaDB, we're gonna use OpenAI models just for simplicity, okay? So the code is very simple. Let me run here. I'm importing the tools, right? I have my OpenAI key here, but you can use yours. And then this is how the data looks like in our system. So I have the name, I have the price, the engine year, the country, the manufacturer, and the description. And this description is crucial for us, right? So all of these information are metadata, are information that is there to help us to retrieve good information. But what we are going to embed is the description. This is really important here, okay? So I made here 4 examples, right? But I didn't have much imagination to create more. So I decided to ask ChatGPT to complete the task for us. So let's create some database with 30 cars. So I'm asking to generate more 26. So here you can read how this works, but I'm generating details for a car that includes the name, the price, engine, year, country, manufacturer, and a description, right? So I want countries for some specific cars from specific countries, just for simplicity. And yeah, let's wait for it to run. That should not take longer. But the idea here is to have a good database that I can search my cars. So as you're gonna see, the cars make no sense sometimes. And let's wait a little bit. It shouldn't take more than 1 minute and 20 seconds. But yeah, this is the code. So this is how the cars or the generator cars looks like. So for example, this weird car name has this price. It's an electric car, the year, the country, and the manufacturer, and also the description, right? So this car is a cutting-edge electric sedan that combines luxury with sustainability. Good catch. We also have this from Sakura Motors, all-electric sedan designed for eco-conscious drivers and things like that, okay? Okay, it's in the 25. Let's see. Let's continue here. It will eventually it will finish. Yeah, here we go. It finished. So this is now our last 3 cars. Now it's a Samurai S series. It's from Japan. So how we can store this data or this list of cars into our ChromaDB. The first thing that we have to do is really simple. We create one client from our ChromaDB. And this is very simple. This is an in-memory vector database. If you're using a different one, a more robust with deploying the cluster, there will be some functions here, some helper functions to connect to the database and everything. But yeah, this is more coding than everything. But here's the client, and we are creating one OpenAI embedding functions, right? So we pass here our key, we pass here our model. So in our example, we had the GT large. I'm using now the text embeddings at a 02 here as embedding model, right? Then I can create one card collection. And this is important because here I define my card collection or my collection name, right? I'm also passing the embedding function. So every time I ask to either embed something or query something, the function that I'm using is this one, okay? And as a metadata, I'm saying, hey, I'm using here cosine similarity as a metric to compare the vectors. This is really important. This is where the magic happens and make ChromaDB very simple for this kind of POC or notebooks, okay? Here's some data processing, getting the car IDs, getting all of the descriptions, and getting all of the metadata. So really important, these parts. And what I have to do to add those things into my collection or to add those things into my ChromaDB is just take my collection, add, and I can add everything in a single line, okay? So when I run this, I should be able to create, oh, yeah, because this one was in memory, sorry, let me just create another collection. So what will happen here is now I have my car collection here. The name of my collection, instead of cars, it's car. The error is because the cars was already in memory. You cannot create again. And then I'm using here something just to demonstrate how the data is in our vector database, okay? So this is a pandas data frame. So we have the country, engine, manufacturer, the name, price, and as the final column here, the embeddings that was created, okay? So this is our vector database. This is our embeddings. And let's start querying things from our vector database. How do we query things from our vector database? So imagine here that I have 5 different users. The first one want a comfortable car for family. The second one is sporty car. And the third, eco-friendly electric car. The fourth, luxury sedan. And the fifth, affordable car because he is a student or she is a student, okay? Randomly select one of the prompts here. I don't want to bias anything here. And what I can do is as simple as car collection, query, and the query text is my prompt. So I'm passing my prompt and the end result is my K, or how many outputs, how many answers I want from my vector database. When I run this, I'm just getting here the results and the metadata here, so I can display a nice text to you all. So when I run this, I see, hey, my user prompt is a sporty car with high speed and acceleration. So I'm getting this thunderstrike. This is my cosine similarity, not great. It's a combustion engine. It's car from the United States, but we should look into the description. So the Thunderstrike is a sleek, powerful sport car designed for speed enthusiastic. So it seems like our vector database returned one description that matches with my user prompt. Sporty car, high speed, acceleration. Yeah, it seems to be a good choice, right? So, but yeah, the country is from the United States. This is the year. What we can do to improve our search is to add some metadata here. So imagine that now I don't want a car from the United States, which is here. Let's see if I get a car from Japan. So I want a car now with the same prompt, but I want to filter only Japanese cars. So I can add this where field here, argument here, and then I can catch not only the first one, but the top three. So let's run this and let's get information now only from Japan. So I asked it for 3 results, then I got 3 results here. With the given cosine similarity, they are very close to each other, but the third result is the most relevant one. It has the highest cosine similarity. The country is Japan. This is the manufacturing. And let's see the description again. So it's a high-performance hybrid sport car that seamlessly merges the power of a turbocharged gasoline and so on and so forth. So again, it seems to have a good match. Now I'm filtering for Japanese cars. Okay, so we can also add this metadata in the query to make sure we get specific data that we really want. Finally, we make the context part. We are getting a good context, or we are doing the context retriever. And what we want to do now is to enrich this context with the prompt. And my prompt is create a friendly and engaging message for a car buyer who wants to buy a car with the context. So the prompt, the request from the user, and interested in car name, car country, the price, the year, the engine, the car manufacturer. So I'm adding those informations into my prompt to make sure that context is inside my prompt that I'm passing to my model, okay? So when I run this, what I get as an output is one personalized message. So you are the hunt of a sporty car that exceeds high speed and blah, blah, blah. So it gives us one of the choices that we want with a hybrid, with turbocharged and everything, okay? So here we finish the loop of a RAG with the context and enriching our LLM answer with the context and coding perspective. I'm adding here the context that was retrieved together. Step 7, step 8 are additional topics that I'm adding here. So I'm creating some kind of image using this prompt. You can double check. Another additional feature that I added into this notebook is re-ranking. So imagine that these 3 cars here are selected based only on the cosine similarity. And maybe this is not the best approach. I can re-rank my results. So I take these 3 results and ask your LLM to say, hey, is this really relevant? Can you classify from 1 to 0 or 1 to 10 if this is a really good match with my prompt? So we can re-rank the results here. And I added this as an example at the end of this notebook. You can double check how it works. You can run by yourself. And yeah. So this was the presentation. This is the live coding or the sample notebook that I would like to share, how it works in action. And I also add some extra information here at the end of the notebook. Thank you all for being here. Thank you all for sharing the quizzes here. And yeah, let's go to the Q&A. I'm looking forward to it. Karan, back to you.
Thanks, Thiago. Very detailed and an insightful presentation. Yeah, let's open the floor up for 10 minutes. You have any questions, please post them in the Q&A tab. We're happy to take all questions here. Let me start with the first one. The first one comes from Bruno. So Bruno asks, multimodal models are also called LLMs, even though they don't process only text. For example, it's common to call GPT-4o and Gemini LLMs, but they also process images. I guess he's looking for a confirmation, Thiago.
Oh, okay. Yeah, it can be used. You can ask an LLM or you can ask ChatGPT to embed something for you. But again, ChatGPT is much more larger than one embedding model. So maybe you're not getting the repetition that you want, the same context if you ask to embed twice or 3 times. But it's really expensive to ask ChatGPT to embed for you. So best scenario, you go to Hugging Face, you get one specific embedding model for your use case, either text, image, or multimodal, and use that specific model. It will be cheaper, it will be more reliable than ask for a random LLM to embed for you.
Got it. Bruno, let us know if that answers. If not, please put in another question. We'll be happy to take up anything here. Okay, the next one comes from Lorenzo. So Lorenzo asks, have you ever implemented a semantic cache? Which threshold worked for you? Would you recommend it?
Oh, semantic cache. Yeah, this is a good thing. To be honest, semantic cache, I haven't implemented. What I have implemented is the semantic search and re-ranking with some semantic layers. But there, what worked for me was actually re-ranking, adding a semantic layer before putting into the LLM the context, and adding what we call guardrails to make sure our LLM are not hallucinating. I hope it answers your question, but because cache can be an extensive topic as well.
Okay, I see a follow-up question. I think that's the question got sort of divided into parts, but the follow-up is any evaluation recommended if we don't want to use RAGs, any other choices?
So let me break into two here. So we have a way to evaluate our RAG system to make sure or to be more accurate if it's reliable or not. We have some metrics to evaluate both context retriever side and generator side and make sure we using metrics, actual metrics, to make sure we are getting good results. But also we have agentic solutions that can be used instead of RAG that can lead to better results. Okay, and the way we evaluate can be different, but yeah, we have this option. I don't know. I don't know if I answered the question,
Okay,
but yeah, this.
Thiago, there's actually another part of the question that I didn't read for you.
Okay.
Let me read this entire thing again and see if you can answer that. So, any evaluation recommend if we don't want to use RAGs, are there any other choices when fine tuning is necessary and RAG is not enough anymore?
Now I got it.
Okay.
Yeah, right. Let's. So the base is RAG is not enough. Okay, maybe fine tune will not be enough as well, because if you fine tune today, tomorrow you don't have the data for tomorrow, right? You would have to constantly fine tune your model. So maybe fine tuning is good for one scenario, but it's not the solution, or it's not the alternative for RAG. One alternative for RAG that it's really a hot topic as well is agents. So you can use agents, and again, it's a whole conversation about agents, but you can use agents to improve your RAG system and get better results. So imagine agents like LLM talking to each other to make sure that the output is good enough. You can have one agent to make requests to the vector database. You can have another agent to verify the output, and so on and so forth.
So, multi-agent approach.
Yes, exactly.
Got it. Okay, I hope that answers your question, Lorenzo. If not, feel free to ask a follow-up. All right, the next question is, can I vectorize my entire code base and automate updates from GitHub?
I think you can if you have access to your whole GitHub repository, and I really think that GitHub does it in some at some level to give the copilot, right? But you have to analyze the cost of storing this amount of data, and also one important thing during your ingestion pipeline, you have to make sure you're ingesting good data, not bad data. So it's possible, but there is a lot of trade-offs that you should consider before ingesting data to the vector database. But it's possible.
Got it. Okay. The next question is probably not for you, Thiago, but I'll just read it out loud. It's from Paula. Says, I'm not sure what is the best words to use. I'm trying to familiarize with LLMs and RAGs. As a Udacity student, have you provided a course related to integration between OpenAI, Python, and RAGs, databases related all together in one course? What type of course is it?
Uh,
Okay.
should I answer that? Okay, go
Yeah,
ahead. Sorry.
if you want to take a crack at it, yeah, sure.
Yeah, I have experience with the. I'm a reviewer for the generative AI Nanodegree, and it covers, I mean, all of the topics that we discussed, all of the topics that are in your answer. So please feel free to enrich my answer, Karan.
Okay, excellent. So Paula, the answer to you is we have a program called Generative AI Nanodegree. Feel free to check that out, and if you have more questions, we'll be happy to sort of answer that. Uh, the next question comes from Francis, and Francis asks, in the second to last slide, why do we have two prompts?
Yeah, good question. Good question. That may be something that confuses, but the first prompt on the left side is more like a question, right? Is that prompt from the user? Can be a prompt from the user asking something that you make some filters, you make some data processing on that prompt, and you extract what the user really wants. For example, if the user write a prompt, hey, I would like a car that has these and these feature, maybe you have to work on the prompt to, hey, the feature one, feature two, feature three. And then this specific text, which I'm calling here prompt, is passed to the vector database. So prompt here is a question to the vector database on the retriever side. Can be a prompt, can be a question. It's a piece of text that you want to vectorize and ask to the vector DB. So yeah, it has not a right name for it, but it can be a prompt, a question. It's just some piece of text that you ask the vector database.
Got it. Okay. The next question comes from Rami. Rami asks, how can we evaluate RAG apps?
Yeah, this is a good question, and maybe this is one of the most important questions when we are trying to put a RAG system into production, how we evaluate it. In a nutshell, we have to evaluate not only the whole RAG system, but we divide into the context retriever and the generator, and we can evaluate those two separated. So how relevant is my context and how good is my generation, or how good is my generated text being compliant with my request, my task, right? And you can evaluate the whole thing together. Basically, what you do, you have something called Ragas, which is a framework. You can take a look at it. So it contains a lot of information. It's a Python framework that you can use to evaluate your RAG system. And
Can you
again,
can you type that out, Thiago, in the chat? Can you just type that framework
yes,
out?
and Ragas. And I will also take the, here we go. And I'll put directly into the metrics where you can see all of the metrics available to evaluate your RAG system. But at the end, you are using either text comparison and also LLMs to make this evaluation.
Got it. Okay. There's one question. I'm not sure if this is complete, but okay, let me ask this. Uh, Agents is what ChatGPT uses. Am I right?
Could you please repeat, Karan?
The question is, agents is what ChatGPT uses. Am I right?
Oh, yeah. I think this we I will speak for me. I don't know what architecture ChatGPT uses under the hood, right? Probably it's agents, or if it's not agent for all of the models, or for example, the most recent ones, it has some features to generate the code, specific code snippets and generate notebooks. So maybe for some of the architecture or for some of the models they provide, there are agents there, but I'm not entirely sure about the whole infrastructure. We don't have access to it, right? But yeah, if I would design something, that one of the first thing that would come into my mind are agents.
Got it. All right. I see another question. Is it essential to understand the transformer mechanism to learn LLMs?
Ah, by the book, yes. You should use this knowledge to improve your understanding about the different LLMs and why one specific thing is different from the other. Uh, But if you want a fast real hands-on, you wouldn't need to understand the basic. But as you grow in your career, as you want more, that's definitely one knowledge to have.
Got it. We have another question from Rami. Is Gen AI more suitable to AI ML engineers or backend developers?
Yeah, this is hard to answer. It will depend on the company that you are working. Maybe backend developers are working with generative AI as machine learning engineers are working on different companies. The point is, be prepared to work with it. It's coming for us. We should, as a developer or as a machine learning engineer, in different levels, machine learning engineer probably will deploy self-hosted models, but also request those APIs to embed the answer into system as well as backend engineers. Depend on the company, I would say that.
Awesome. Thanks for that, Thiago. Those are all the questions we had. Folks, if we missed any questions, I apologize.
Yeah, Karan, I think one question has just came up. So if you
Okay.
can just go through it. Okay, let me read out. I'm still trying to understand the vectors. My question is around vectors DB. Can two different vector DBs be used to integrate?
Yeah, I don't see any advantage to have two different vector DBs, right? I really don't see the advantage to have two vector DBs here because one vector DB to store the vectors are enough. It will depend on the architecture, but I don't see any advantage to have two.
Got it. Thank you. Thanks, Aisha. I believe we've covered everything now. Okay.
Yes. Yes.
Awesome. Folks, if we missed out on anything or if you have any questions post the session, you have a Google form attached at the last slide of the deck that we've put in the chat. Feel free to put your questions in the Google form. And what we'll do is we'll try and get Thiago to answer all your questions sometime next week. And we'll sort of put out a document that you can read through. We do that for every session. So yeah, feel free to put in any questions that you have, and we'll do our best to get back to you. Um, this is a wrap for our series for 2024. However, we'll be back in 2025. We'll be back in mid of January. The next session actually sort of builds on this topic, and the next session, I can tell you the topic. It's basically powering LLMs with knowledge graphs. So that's the topic of our next session, and we'll be back mid-January. So I believe the next session would be 14th of January is when we'll be back. We don't have a calendar as such that you can read through, but you can stay connected on socials. If you're an alumni or if you're a current subscriber, you can stay connected on our community platform on Circle. Updates go out there as well, and we send out emails 1 week before the session is scheduled. So keep an eye on your inbox, and you'll find the registration link to that session out there. Right. Yeah, before we sort of wrap up, there's one small request. We'd love your feedback on the session. And after you sort of log out from this session, you'll have a small pop-up appear in your browser window. And we have a very short feedback form. It's just 3 questions. Two of them are multiple choice, and there's one optional open-ended text question. So if you want to express any thoughts, you can do that. Otherwise, it'll just take a minute of your time to just answer a couple of questions, and that is really helpful for us to refine and improve in future sessions. And with that, I'll wrap up. I'll take your leave. I'll wish you a happy new year in advance. Take care. Have a wonderful time with your friends, family. Have a wonderful weekend ahead. And I'll see you till next time. Thank you all. Bye.
Bye bye. Thank you all.